Welcome to all students in subject of design of transmission system. Today we discuss about helical gear numericals and beam strength of the helical gear tooth. First we discuss about problem. In problem there are some values are given. Power is equal to given in kilowatt 5, Na is equal to 720 rpm, ZA is equal to 20, ZB is equal to 30, Mn is equal to 5 mm, psi is equal to 30 degree, alpha n is equal to 20 degree. So, components of tooth force, Ft is equal to tangential component, Fr is equal to radial component and Fa is equal to axial component. So, as we know that Ft is equal to mt upon dA by 2, mta is equal to 60 into 10 raised to 6 into power kilowatt 2 pi Na. dA is equal to ZA ma upon cos psi. So, putting this value, MTA is equal to 66314.56 Newton per mm. dA is equal to ZA Mn upon cos psi, that is equal to 20 into 5 upon cos 30, that is equal to 115.47 mm. So, Ft is equal to 2 into 66314.56 upon 115.47, that is equal to 1148.6 Newton. So, this is the solution. Ft is equal to 1148.6 Newton. Fa is equal to Ft times tan psi. So, Fa is equal to 663.14 Newton. Fr is equal to Ft tan alpha n upon cos psi. So, Fr is equal to 482.73 Newton. So, free diagram of forces. The direction of three components on the gear on the point 2 will be opposite that of pinion. Now today we discuss very important topic, beam strength. Beam strength of helical gear is a very important topic. Helical gear is equivalent to an imaginary spur gear, that is virtual spur gear, in a plane perpendicular to the tooth element. To find the beam strength of the helical gear tooth, the helical gear is replaced by imaginary or virtual spur gear in a plane perpendicular to the tooth element. For beam strength, the helical gear is considered to be equivalent to a formative spur gear. The pitch circle diameter of this gear is D. The number of teeth is Z and the module is Mn. The beam strength of the spur gear is given by SB is equal to MB sigma By. So, beam strength SB is the maximum value of the tangential force that the tooth can transmit without bending failure. For beam strength, the helical gear is considered to be equivalent to a formative spur gear. The pitch circle diameter of this gear is D. The number of teeth is Z dash and the module Mn. The beam strength of the spur gear is driven by SB is equal to MB sigma By. This is the diagram of helical gears. In this diagram there is mentioned psi, SB, center line of tooth, then pitch cylinder. The beam strength of the spur gear is given by SB is equal to MB sigma By. So, SB is equal to SBN, that is equal to beam strength perpendicular to the tooth element. M is equal to Mn is equal to normal module, that is B is equal to B cos psi. SB is equal to MB sigma By. So, SBN is equal to Mn B sigma By cos psi. So, in beam strength, there is very important factor Y. Y is a Lewis form factor based on virtual number of teeth, that is Z dash. SB is the component of SBN in the plane of rotation. Thus, SB is equal to SBN cos psi. So, SB greater than F effective. In order to avoid the failure of gear tooth due to the bending, the beam strength should be more than the effective force between the meshing teeth. The standard value of Levis form factor based on virtual number of teeth for various tooth systems are given in table. So, Ft is equal to mt upon d by 2, that is equal to 2mt upon d. When gear rotates at very low speed, the tangential load Ft can be considered as actual force between two meshing teeth. But when gears rotate at high speed, then it is necessary to consider the dynamic force resulting from the impact between meeting teeth. The dynamic force is induced due to inaccuracies of tooth profile, errors in tooth spacing, elasticity of parts. There are two methods to account for dynamic load. First is approximate estimation by velocity factor CV in the preliminary stages of gear design, and second, precise calculation by Buckingham's equation in the final stage of the gear design. In the preliminary stages, the effective load F effective between two meshing teeth is given by P effective is equal to CS Ft upon CV. CS is equal to service factor and CV is equal to velocity factor. The velocity factor for helical gear is V greater than 20 meter per second. So CV is equal to 5.6 upon 5.6 plus root of V, where V is the pitch line velocity in meter per second. Now we discuss about very important point, that is effective load on gear tooth. In the final stages of gear design, the dynamic load is calculated by equation derived by Earl Buckingham. The dynamic load is given by Fd is equal to 2Lv CEB cos square psi plus Ft cos psi upon 21V root of CEB cos square psi plus Ft, where Fd is equal to dynamic load, V is equal to pitch line velocity, E is equal to sum of errors between two meshing teeth, B is equal to face width of tooth, Ft is equal to tangential force due to rated torque. The effective load is given by P effective is equal to CS Ft plus Fd, where Fd is the dynamic load or additional load due to dynamic condition between two meshing teeth. Also, there is very important point is permissible bending stress. The permissible bending stress or bending endurance strength for helical gear or pinion is similar to spur gear. It is given by sigma b is equal to ultimate tensile strength upon 3, where SU2 is ultimate tensile strength is equal to ultimate tensile strength of the gear material in Newton per mm square. So, dear students, today we discuss about beam strength of helical gears. This is the very important topic for this design of transmission system. So, thanks all of you.